Welcome to Study Loop.
In this problem, we have a box that is being pulled upwards by a tension that is varying with respect to time, and the force of gravity, which is pulling it down. For this problem, I'm going to orient my coordinate system so that the positive y direction is upwards. So Newton's second law in the y direction implies that tension minus mg is equal to mass times acceleration. Now, part A of this problem is asking for velocity at various points in time. The strategy is to first find A and then integrate it to find V. So plugging in what the known form of t is along with the masses and solving for A, I get that A is equal to 36t over m minus g, which is equal to 12t minus 9.8. And I'm leaving units off because they're all already in the SI units. And so I can just add them in at the last second, knowing that the answers will be in SI units as well. So now that acceleration is in this form, I can integrate it to find velocity. The integral of this is straightforward. You just add to the power and then divide by the power. So I get 6t squared minus 9.8t. And then you would normally add an initial velocity, but we're told that's 0. So this is the actual form here, upon which v of 1 second, this is now a calculator problem, becomes negative 3.8 meters per second. So after 1 second, gravity is winning the battle, and it's moving 3.8 meters per second downward. But then you'll see v at 3 seconds is equal to 24.6 meters per second. And so eventually, because the tension is time varying, it overpowers the gravity and it starts moving up. Part B of this problem is asking how far down it went at its maximum value of distance. And so first, we want to figure out how long until the velocity is 0. Because when the velocity is 0, that's when it's at its deepest point. And so we can take the form of v at t right here, and we can set it equal to 0 to figure out what time values yield 0. When I do that, I get 0 is equal to 6t squared minus 9.8t. Now, t is equal to 0 is an obvious solution to this because at time is equal to 0, the velocity was equal to 0, right? The initial velocity was 0, but that's the uninteresting solution. And so I'm going to divide that out, and I get 0 is equal to 6t minus 9.8. And this yields the interesting solution. T is equal to 1.63 seconds. That's not the final answer. Now, what we want to do is find x of t by integrating v of t. This is, again, a simple integral. It ends up being 2t cubed minus 4.9t squared. And now, if I say that x naught is equal to 0, this is the true form of it. And now I plug in the time until v is equal to 0, and then I get the x value that is the smallest. So plugging this time into here gives x of 1.63 is equal to negative 4.36 meters. And that's the answer to part B. Part C is asking the time until the box is back where it started. And so for this, we can set x equal to 0 and find out what time solves this. We found x of t here, and you'll see that t is equal to 0 is, again, a solution, but it's an uninteresting solution that we don't care about because obviously the initial position of the box was at 0. We care about the later time that it was at 0. And so dividing this equation out by t squared gives us 0 is equal to 2t minus 4.9. And then we get our solution that t is equal to 2.45 seconds. That's when the box has reached its original point again. And that's